Hello, it's Duncan. Eagle-eared viewers might have noticed that I've been threatening to introduce the reader monad for a couple of episodes now. In contrast to context receivers, which we covered in the last episode, functions using reader monads signal that they need some context to run in their return type rather than their input types, returning a function that will be executed later rather than straight away. This is the most advanced topic I've addressed in the channel so far, so if you haven't watched the previous episode, I would do that now. I'll put a link to it up there somewhere. Assuming that you have understood context receivers, sit back and let this refactoring wash over you the first time, then come back and watch it a second time after a warm bath. In the last episode, we came up with this scheme where the methods on items have this context that tells Kotlin and programmers that they need to be run in the context of a transaction. But how could these methods signal through their return type that they needed a transaction? Well, let's take this load case, and instead of saying context load, we'll just say load. And now instead of returning a result as stock list, we'll return something that says it needs a transaction in order to run. So we'll call that requires transaction. It doesn't exist yet. And it needs to signal the type of that transaction, and around here that is TX. And given that transaction, it's going to yield the same type as our normal load. So that will be a result of stock list or stock list loading error. And I think I said requires transaction. That would be a better name. Now that type doesn't exist, so let's bring it into existence. And we'll put it in here. And we'll tell it that this is TX for the transaction type, and this is R for the type that it will return. And let's go over to our items contract and sketch how we might use that. I'm going to add a test in here, which we'll call requires transaction. Now I think to demonstrate, I'm going to start with the required transaction version of save. So let's write that. We'll duplicate this, put it in here. This would no longer be a context function, but given a stock list, it would return requires transaction. Given a transaction and returning a result, stock list loading error. So now over in our test, I'm going to say items save our initial stock list. And then we'll load the stock list and show that it has been saved. So we're going to say, we can take our previous code, which used items in transaction. Maybe we'll take something like this and say that this should be success of initial stock list if we go and load with the old load. Okay, let's just try running that. We have a couple of problems, the first of which is that the compiler now gets confused between these things with the same name. I'm going to change this one's name to save2 and this one's name to load2. I don't know whether the compiler will ever get smart enough to solve that problem, but we'd have to go and change over here. So this would be save2. Compile again. At this time, we had the problem we don't have implementations for these two methods. To solve that problem, I'm just going to say to do, to at least get us running. And now let's go. And now we're getting this issue with not implemented. I'm just going to shift this that way a bit so we can see more of that right-hand side. Okay, now we were to doing in here, but we don't actually have a type here. It requires transaction, so we could return one of those and run. And now we compile, we run, but the test actually failed because we haven't actually saved stock list. Well, that shouldn't surprise us because we never actually went through the implementation of this save method at all. What we're going to do now is we're going to have requires transaction as a class. Remember what it would do with the transaction if it was given one. Remember that as a property, you call it f, and that's going to be a function that needs a transaction, tx, and returns whatever we said our result was, that's r. And in here then, we can pass a lambda. You see IntelliJ is telling us that the it in here is a transaction, so we can set up to call this save. If you remember, we use with in that case. So we say with it, which is our transaction, and then we can call the other save. Well, that compiles, let's run it. And it still fails, and it fails because whilst we've remembered what we want to do when we have a transaction, we haven't actually called this f at all yet. We're going to add a method to here, and we're going to call it run with transaction. That is going to need the transaction from somewhere. So that's going to be tx, which is our transaction type. And if somebody calls that, we will call the function we were given, passing it the transaction we've just been given. And now over here, Let's just remind ourselves the return type of this is our requires transaction. So this isn't actually saving anything yet. It's a thing that will save something later. I think we'll call it saver for now. So now we can take our saver, which is a requires transaction, and we can say saver dot run with transaction. Now you can see run with transaction needs a transaction. Where do we get one of those from? Well, the answer is in an items in transaction block. But now we have a problem because this in transaction provides a context receiver and not a parameter we can use. We can solve that problem just by making this here a context function itself. Back over here and we'll say this is context tx. And if it was, then we wouldn't need to pass in a transaction here. And we could take the transaction to call our function with, which is this at the name of the type, which is a bit strange and pass. Let's try that. And now our tests are passing. In fact, we can generalize that context a bit. We do the same thing here. We can say instead of taking a transaction, this f requires a transaction in the context. It's going to be context of tx. Now no longer takes a parameter and should actually go right-hand side. And now here we don't need to set up the with it. We can just call our save. That can go, reformat, and run. Wonderful. I'm going to remove this type signature here. Keep the separate object so we're reminded that nothing happens until we run it with transaction. So let's just remind ourselves of the key points here. Save2 doesn't actually do anything. It just remembers what it would do. It returns this thing called requires transaction that remembers the block of code that it will run when run with transaction is called on it. So this does nothing. We need to call save a run with transaction to actually run the code. Okay, on to load. What we're going to do is we're going to simulate loading and then saving a changed stock list, which is what happens when we update when the day is clicked over. So now we know that we've got initial stock list saved. So now I'm going to say something like loaded is our items load to, and we know that returns a requires transaction. So we can say run with transaction. But we can't do that except in a transaction block, so we can do items in transaction around it. And now I'm going to shift this way because this is going to be the long side. Okay, what's the type of our loaded here? Well, it's unit. That's no help to us. We want it to be our stock list. So we're going to go over here and say that run with transaction had better return the R that is the result of the block, this F, by saying return and make that an expression body. Now this would be a stock list, but it's not. It's actually going to be a stock list result, I think. Let's just check. That's a result of a stock list and stock list loading error. And we know that what we do with results is that we flat map on them to only run if what we have is a success. Inside here, this can be stock list. And let's take that stock list and update it in some way. We'll take the stock list and we'll copy it and we'll set its last modified to be the stock lists, last modified, plus an hour. IntelliJ isn't very happy for some reason. And now we'd like to use that updated stock list and we'd like to save it. And we'd like to use save2. So now we can say items save2 given our stock list. That requires a transaction to commit. So we'll say run with transaction. But I should have said in here that I want not the stock list, but the updated. Now run with transaction will be returning the result of the thing we've just saved. So this in fact is going to be updated, I think. Let's look at its type. It's our result, the stock list and stock list loading error. So now we can say, well, first of all, we expect that updated should be a success of our modified stock list. So this is in fact our initial stock list copy given the initial stock list last modified plus an hour. That's going to be last modified. So we're doing the same thing here. And let's just try running that. Oh, now we're failing because of this to do. Bit of a shame, but in fact we know how to convert over here from a context function to a non-context function. We just return requires transaction on the context version. This is going to be load and a little bit of tidying here to make that an expression. Same thing here. We're delaying our gratification when we call run. Everything passes. Before we go on, we should just check that we have actually saved at all. So I think we should say same sort of thing as we had here in here after we've done the thing. We could pull this here into a variable, one up, expected. And then this will be dated, the thing that comes out of all of this. If we remember it, then we can say we expect return value of all this block to be expected, and the same here. This is going to be expected. Inline that and run. And probably just pull this down. Yeah. Good. Now this run with transaction, flat map run with transaction seems to be an awful lot of ceremony. So let's see if we can generalize what we've got there. So to generalize this, I think we'll take this piece of code here, because that's the thing that's specific to our stock list. So in fact, let's take that and bring it out into variable. And now inline this updated. Now the tests. And now the type of this is a requires transaction. We probably knew that because we were calling run with transaction here. So what I want to do is bring this out as a block of code. I'm going to make it into a lambda. And I'm going to invoke it here. So that's the same thing effectively, but this is using stock list that comes from here. So what I want to actually do is make that stock list a parameter to this lambda so I can bring it all out. This is stock list, which is a stock list. And now I have to pass the stock list we have up at the top there into here. Run that. And that means that I can take this out of here. Because it's a lambda, I'm not going to be running anything yet, so we can define it outside all of this block. Let's check that's true. And it is. What am I trying to do here? Well, I'm trying to extract the specific things about stock lists from the things about requires transaction and result types. Because now, as far as this block of code is concerned, this is just some operation. It doesn't care what it is. So let's just rename that to be operation. And now we're going to take this code here and extract a method out of it. Don't know what to call it yet. Let's go and find that. Here it is. Now this hasn't compiled because the extract refactoring didn't take into account the fact that this needs to be a context function. So this requires context of transaction to be able to call run in transaction. That seems to need to be outside there for some reason. Let's run that. And everything still passes. Now this is pretty general, but it still specifically calls this items load to. So let's take that and make it a parameter. And we'll call it anything we like for now, because we're then going to make it into a receiver and run. So now, back up here, we said we're going to get items, we're going to call load to, and we're going to call whatever this thing is on it. So for now, I'm going to call that and then. Now with luck, this will not depend on anything in our items contract. So we can pull it to the top level. Do that, cut it from here, paste it. You see, we're not quite as lucky as we want to be because we've got this transaction type which was bound to the items contract, but we can fix that by putting a TX in here. Let's try running that. Good. This is a very busy definition. We can make it slightly less busy by saying we don't actually care about any of these types. So let us add a type parameter for the result type and a type parameter for the error type. Messed up a little bit there, but we'll get rid of that. Now, we don't actually care. R doesn't need to be anything to do with stock list. And the error type doesn't have to be anything to do with stock list loading error. But you see, we do have a problem up here with our types. And that's because we have two different error types, stock list loading error IO, the specific one, and stock list loading error, the more general one. We can fix that by introducing two error types here. We'll have E1, we'll rename this one to be E1, and we'll say the second operation here can return an E2, providing that E2 is a subtype of E1. That should allow us to delete this and compile and pass the tests. While we're generalizing, this operation here at the moment is returning the same R, but it need not. We could put in another R, so we'll rename this one to be R1. We'll put in an R2, and we could say that if this operation takes an R1 and returns the result of R2, then that would still work. Compile and pass the tests. All right. Before we go on, I'm just going to go an inline operation so we can see what things will look like there. So now you can see what we have is we say items load to, and then given the stock list that's a result of loading that, items save to. What's the type of that expression? It's a result of stock list and stock list loading error. We can say down here like that. So this thing we've called and then is called on a requires transaction, takes a function, returns the requires transaction, and returns the result outside of the required transaction. Now that's a bit asymmetric because our initial saver, for example, returned a requires transaction. But let's just fix that. What we'll do is we'll wrap all this, take out the return type for now, and I'm going to wrap this in requires transaction. And IntelliJ won't tell us the type, so we'll tell it that that is requires transaction of tx, and it's going to return a result of our R2 E2. And I've messed that up a bit because the actual type of this result is going to be the E1. And this is not actually a stock list anymore. Well, it can be a stock list, but it is in fact just whatever our first result is. Now, having changed that, up in here, we take this block and we run with transaction on it. And that passes everything. And now returning to this and then has the same signature as flat map. So if we look at flat map on result, for example, it takes a result, something that returns a result, and returns the result. Here now, we take a required transaction, something that returns a required transaction, and we return a required transaction. So let's call that flat map. Okay, you can take this, cut it out of here, and add that over here as part of our requires transaction. And we'll make it public. Good. This horribleness, though, is very specific to requires transaction where the return type is a result, because it uses flat map here on result. There's also a flat map on requires transaction that doesn't do this intermediate flat map. Let's have a look at what that would be like. But before we go on, I think that we don't need this context here anymore. See whether that's true. Oh, it is good. It just happens to be that we were always calling it in this in transaction block here, but we needn't have done that. Okay, back to requires transaction flat map. That will be a method, and we'll call it flat map, and it will take some operation. We'll put F2 because we've already got F1 above. And that operation is a context function. It also requires whatever transaction we needed, takes some R2 and returns the requires transaction of our transaction and R2. In order to compile it all, this will need to know that there is some type R2, and we could just do that for now. If we just put that in braces. Now our test over here is broken, and that's because it doesn't know which flat map is which. I think we'll call this one flat map result. So that's what we're doing in here. It's a specialized version. Does that compile? It does. And still passes. Good. Okay, back to our flat map here. We've got a pattern for what it should do in flat map result, which is to return a requires transaction, given our tx and our r2, returning our r2, where inside there, we're going to say this dot run with transaction. That's going to be our R1. Let's just remember that for now. And then we can call for F2 on our R1 and run with transaction that. And I've slightly messed this up because this function 2 here doesn't need to be a context transaction because it's returning a requires transaction. It is going to take our initial R. Now we can inline this. And that's what flat map looks like on our base requires transaction. Now we've got here, though, nothing about this requires transaction is actually anything to do with transactions. It's just to do with some sort of context. So we might call this requires context equally well, where this is just C, and we would rename that there. And once again, I've messed up the spelling. And this requires context is now what functional programmers call the reader monad. It's a monad because it has flat map. There are other monad rules as well. But the key thing is that it takes a function that needs a context. It reads from a context in order to work. And you can combine that with other functions that have the same requirement. So now we could call this reader. And then this would be not run with transaction, but run in context, which makes sense given that it requires this context here. A bit of a shame this flat map here is unused, but we can implement this flat map result in terms of it by saying this is flat map, which will give us an R1 result, and that will return a reader that takes that R1 result, flat maps it to give an R1, applies our operation to our R1 and runs that context. Get rid of this old version, one more brace, reformat, and if we write our test, we'll pass. They do. And then last little tweak, this we can just rename F, as that's been good enough in other places. So to recap, reader is a thing, the monad, that wraps some code that requires some context, something that's going to be read. It allows us to combine that code with other code that needs the output of the first code, but also requires a context still, giving us back a reader that we can run in a context when we have one. Again, over here, nothing is happening in this block until we call running context, because we've remembered this F. We haven't actually evaluated it until this point here. Well, I don't know about you, that's pretty exhausting. It's complicated. And it's not clear to me that it brings things to the party that our initial context functions here don't bring. So I think having done all this work, we're probably going to throw it away. But just before we do, I've got one more trick up my sleeve. We've created this reader class to hold this function for us and to host these operations, running context and flat map. The question is, do we need to? One way to pull on that thread is to try and make this a value class. We do that and can pass all the tests, then we know that this function is just being passed around as a function rather than actually instantiating one of these classes. So that suggests we should be able to just work on this function. Let's have a go at that. Go back here, and what I'm going to do now is I'm going to say that my reader implements the type of the function inside it by the function inside it. And I think we need to put that in brackets to make everything compile. That shouldn't break anything. We'll run the tests. Good. Now what I'm going to do is I'm going to convert this run in context to an extension function. I'm going to do that with the refactor. And that shouldn't have changed anything. And hasn't. We're going to do the same thing with flat. And run again. Good. Now though, our reader implements this function type. So we could make these extensions on that function type rather than our reader. Take this here and put it here and here. But now we lost this F, but this F actually just works out to be invoke on that function. Check that by running. And we're still good. Now I'm going to extract a type alias for this type here. And we're going to call this reader2 for now. There's 6 places where we use that, so let's all of them like that. Now I don't know what the compilation error is here. It's a bit odd. This flat map is there, that's okay. But I think here we probably need to return reader2. This flat map will itself return reader2 of our context 2. And the same is true here and here. Well, that's all getting too hard. I'm going to back out and do that by hand, I think. So we were running okay there on the tests. Good. So we can change the type that this is going to return to reader2. Give it a C and R2. That's good. Run that. Now we know that our reader is going to be reader2 of C and R, IF. This here can be reader2. Run and check we're still on the same. page. Good. Another one here. This can be reader 2. And this can return reader 2. And run. Good. Moving up to the top, these can also declare reader 2. And all is good. And now in here, instead of calling the constructor on reader, we can just use the lambda that we were passing to reader. So you see that compiles, and it compiles because reader 2 is a type alias for our function type. And that's what this is. Same thing here. Fix this up to be C and R while we think about it. And now one more reader there, one structure invocation we can get rid of here. And run. Still good. And now the question is, where do we still have a reference to this reader? It's here. But again, here we can just use the lambda. Run that. And now our reader is unused. Delete that. This type alias will do in its place. Run the tests. Well, that was stressful. Tidy up and reformat so we can see what's going on. We can call this F now in context. Put that down there so we can see the structure a bit. And I might normally put the brace on here, but this is a lambda, so that's a bit confusing. If I put the brace here, it looks like a function definition. I'm going to leave that alone. This is always going to be a bit horrible. But here we have reader monad implemented as a type alias and extension functions using Kotlin context receivers. I think I'm going to commit that, if only for posterity, to rename this to be reader monad. And I'll commit this and then almost immediately revert. But it's there in our Git history if you want to come along to GitHub and have a look at it. Details of the Git repository are in the show notes below. Well, I hope you found that interesting. The consensus seems to be that context receivers mean that we don't actually need things like the reader monad anymore. And I think Arrow, for example, has removed its reader implementation in favor of context receivers. But I at least found it interesting to map from one to the other, and this refactoring has really forced me to understand what reader monad is doing. The aha moment for me was reading Roberto Barbini's forthcoming book From Objects to Functions. I found the book hard-going but worthwhile, and I'll give a link in the show notes below. If you're still with me, then wow, thanks very much. That's fantastic. I hope you learned as much as I have. And if you want to carry on learning with me, then please like this video and subscribe to the channel. And finally, while you totally should buy Roberto's book, you should first of all buy mine, a book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.